processing's main purpose is to convert text into numbers. You can hear me, right?
Yes.
Yes, sir. Yes.
So natural language processing's main purpose is to convert text into numbers, unstructured data into numbers. Okay? While converting text into numbers, one thing should be kept intact. The essence of the data should not lose. Okay? So that's the main goal of NLP. Natural language processing will process text and convert text into numbers in such a way that the essence of the data is not lost. What is the essence of data? So there are two statements. Suppose that there are two statements. I like pizza and I like burger. Right? Here, pizza and burger belong to food. Okay, and I like tennis. Right? The tennis and I like cricket. Tennis and cricket belongs to sports. So pizza and burger, when you try to convert text into numbers, like will have one number. Suppose that for each of the word you are giving a number. Suppose that, okay, and you are trying to count how many times that particular word occurred. Okay, something like that. You are trying to do. This is not exactly. Maybe we are doing, but similar to this we'll be doing in NLP. So if you are trying to assign number to each of the word, and then uh, you are trying to use those numbers or count those number of numbers and all that. Okay, so like will have same number. Right? Like will have one number. In all the words, like will have one number. Right? Uh, burger and uh, burger and what you call it, that pizza should have should be given a number that is close to each other, and cricket and tennis should be given numbers which are far from the burger and tennis. That's the essence there. We are trying to convert text into numbers, and parallelly we are trying to keep the essence of the data, right? You got you got it, right? So NLP techniques will try to do that. Okay, in a long document, like maybe 1,000-page document, if you want to look at each and every word and try to assign numbers like that, right, it's not possible, humanly impossible. So the natural language techniques will try to do that. So whatever I explained right now is called as word embeddings or semantic similarity. Okay, but initially while learning NLP, we'll start with syntactic similarity. Okay, so let me write it down and explain a little bit about the syntactic similarity and semantic similarity, and then we are going to reach to semantic similarity at one point in time. Right? That's the more powerful technique when compared to the syn, syntactic similarity. So while assigning numbers or while assigning vectors to text, we should keep the NLP technique should keep the essence of the data intact. That's the main goal of NLP. So we'll start with where we start and where we end up. That's the thing. Okay, this class is going to show you everything at a high level, but this is very important. This is very important. We should know where we are heading, right? Where we start and where we ultimately end up. Right? So there are, suppose that there are documents, right? N number of documents. Maybe we need to predict the sentiment. Right? We have to predict, whether this document is, having positive sentiment or negative sentiment. This is having positive sentiment or negative sentiment. This is having positive or negative, right? So to do that, it is called a sentiment analysis. Okay, sentiment analysis is a classification problem, right? To do this, right, you need to have a data set, right? What is the prerequisite? You need to have a data set. with dark 1, dark 2, dark 3, and so on, dark M, right? Dark M number of documents you should have, and there will be some features x1, x2, and so on xn. What are these features? We'll talk about it, okay, in a moment. And why? We should have a data set like this, where this will be showing you, this Y will be showing you a sentiment score or a positive negative thing, right? 0, 1, 1, 0, 0, right? Maybe 1, 1, like that. When I say 1, it is positive. When I say 0, it is negative. So whether first document has got positive sentiment or second. When I say sentiment, right, either as a whole it is talking about something positively, or a person or a thing, right? It will be, there will be a subject to positivity and negativity, right? So like that. So there will be a data set that is talking about something, right? The positivity or negativity, right? We will use this and build a model, maybe logistic regression, maybe SVM, maybe deep learning model. We still don't know deep learning models or ensemble models, right? So we'll be building a model, and when a new record comes in, we'll convert this new record into x1, x2, x3, and so on xn. What are these x1, x2? I'll talk in a moment. We'll convert these documents into x1, x2, and so on xn, and then pass it to the model and make prediction whether it is positive or negative. Okay, that's an NLP project. Here, these x1, x2, x3, and so on xn's are the words in the data. Okay, the word 1, word 2, distinct words in your data, right, are called are the features, right? If there are when I say words in I actually spoke about assigning number to word, and I'm going to talk in a different way now. So there are two ways of handling NLP problem. One is syntactic. Okay. Another is semantic. Okay. So if I know there is a big corpus, right? Big corpus of documents. These are all documents. Okay. M number of documents here. M docs. Okay. So I took all those M docs and took out all the distinct words from these M docs and made them as features. Word 1, word 2, and so on. So n distinct words, sorry, m number of documents and n distinct words, and made them as columns here. Okay. In doc 1, how many times this word occurred? In doc 1, how many times the word 2 occurred? In doc 1, how many times the word n occurred? Right? Like that. If I do this, right, this is syntactic. Right? Why? Because there are sentences like this. I like burger. Right? Okay. I like cricket. Right? So these are two words here. Right? Are they talking positive or negative? Are they talking about something positive or negative?
A positive, because
Positive, right?
like is a positive word.
Yeah. So if this is a corpus, so I put W1 as I, W2 as like, and W3 as burger, and W4 as cricket. Okay. So in this, document 1, I occurred once. I occurred once. Document 2, like occurred once. Like occurred once. Cricket, burger occurred once. Cricket 0. This is 0. This is 1. Right? Both are actually 1. So if you look at this data, right? If you look at this data, these two cells, right? In the first row, this cell and this cell. In the second row also, this cell and this cell actually are determining, because in one case one was 0, other was 1. In another case, one was 1 and other one is 0, right? This is not determining. If you look at this data, these two or these four cells are not deciding whether this is 1 or 0. We are looking at a simple example, right? To understand, we are looking at a simple example, right? So if you can clearly see that these two cells are the ones which are deciding that this is 1. So right, like is the word, right? So how many ever times we see like, that good, that is actually positive. And again, right, if I have I don't like, maybe something, right, maybe uh, swimming, okay, I don't like maybe playing, something like that. So in this, if you take this as a corpus, right, you will get more words, more features into the data, right? There will be don't will be added into the data set, and then swimming will be added, right? And then playing will be added, right? For those cells, right, there will be 1 and 0, right? Here you will have zeros, here you will have zeros, but here you will have ones, 1 and 1 in swimming and 0 in this, and uh, uh, 1 here, 0 here, and 1 there, something like that, right? So these once again try to make these two records as negative because of don't, right? Even though like is there, because of don't, it is actually becoming a negative record, right? So like that, syntactically also you can actually find out the pattern, okay? So syntactically also you can find the pattern. So this is called as bag of words. So here we are actually putting counts of all the words and trying to create a data set. Use that data set, build a model. When a new record comes in, you are going to convert that also into this bag of words. Okay, and try to make prediction. This far, are we clear? This is syntactic way of handling natural language processing, or a natural language processing problem. Got it? Till here?
Yeah, but if it is the features like x1, x2, or all those count of words, how it is actually taking the essence. So if we say like if we are converting a word into number,
This, so this is one way of doing it. I explained syntactic way. I'll talk about sorry, semantic way. I'll talk about that in a moment. What is the difference between this one and that one? Right? That's the or which one is powerful? That's the question you are asking.
no. It is actually the car. These numbers are the representation of the words, or the numbers are the representation of the counts of the words.
The numbers are counts of the words. So that is what
Yeah.
initially when I started with semantic similarity.
Okay.
Now I am talking about syntactic similarity. I'll talk about semantic also in a moment. More
Yeah.
example.
Let's complete.
Yeah,
Then we will
maybe.
see.
Yeah, let me complete and then we'll talk about it. So this is one way, right? This is actually syntactic way of trying to represent your data. So the techniques that help you convert your data into this kind of data set are called as natural language processing techniques. Okay, there is a lot of theory involved in this, but we are looking at this at a high level. This way of representing data is called as bag of words. Bag of words. This way of representing. You take the you call this as a corpus. Okay, this is called as a corpus. A data set that is maybe train set. Maybe you can say it as train set or corpus. Right. So we'll talk about corpus also very clearly, and we'll take all the distinct words from it. We form a data set like the counts of the words, each document are going to represent the data set. This way, you have acquired some knowledge about the data and you are building a model. Okay. The second way, semantic way. So no, spelling is correct. So semantic way is like I explained, right? So why semantic, right? So no, here I like burger, I like cricket, I love dosa maybe, right? And I love to eat idli every day, right? So these kinds of sentences, these are also positive sentences only. Okay, but here if you look at like and love, they both are actually talking about something I want to eat, right? If you try to represent this kind of bag of words kind of representation, right? The data is going to be like this: I love like, right? Burger, dosa, right? Cricket, right? And then swimming. I am taking only some, right? Swimming, right? Idli. I think that's so, right? That's like so the why very good. Okay. Oh my God. So why semantic similarity is more important? That's what I am trying to explain now. So if you take syntactic similarity, right, for this document, it's going to be for the, I'll say this is doc 1, this is doc 2, this is doc 3, this one I say doc 4 or doc 5. So I'll say idli also. So here, right, doc 1. If you want to represent it in a bag of words way, 1, 1, sorry, 0, and then burger 1, rest of all 0. And then this is 1. Okay, dark 2. I think don't also have to put, right? Dark 2. I like cricket. And rest of all zeros. And in this particular data set, right, we have ones and zeros only. But in some data set, right, you will have higher counts also. Okay, higher counts also. So the dark 3, I don't like swimming. 0, 0, 0, 0, 0 and 0. Okay, dark 4. Dark 4. Where is dark 4? This one. I love, right? 1, 1, 0, 0, 1, 0, 0, 0, 0, 1. And then, dark 5. This is bag of words representation. I love 0, 0, 0, 0. Like this, you represent data. Now, the text is represented as numbers. Now you can, this data set is eligible to do a machine learning model or a deep learning model. Okay. So here, if you look at this, this love and like are actually talking about the same thing. Okay. But because you represented them as two distinct words, right, the essence is actually been spread across. Okay. If you can make these two words into one, if you can make these two words into one, all the places you will have one, right? Suppose that if you can make these two words into one word somehow, right? All the places you will have one. Then the predictive power of positive records will increase. Do you agree? The predictive power of positive records will increase. If you can make those two words as one word, do you agree with that? If computer knows that love and like are same in this particular data set, then the predictive power of the model will increase. Do you agree with the statement? Yes, no.
When you merge, how it will increase the predictive power? Maybe it's not clear to me, sir.
So when you are building a model, if the data in a particular column is having high numbers, will that feature influence the target variable well, or the columns with zeros will influence well?
Yeah, more number will influence higher.
Everybody agree with the Greer's statement?
Yes, sir.
Right? That's the key thing here. We are actually, if you merge these two, right, you will have high count. Right? In a single word, if you have in a single sentence, if you have love and like both, you will get two there. Got it? If it is repeating 100 times, right, you will get a big number there. Right? If not, right, it will be spread across, right? Maybe this will have 0, this will have 100, this will have, right, like that. So if you can combine multiple words, or if you can actually find out similarities between words and then try to create a data set, that will be more powerful than independently trying to create counts for each of those. Do you agree? That is logical. You need to think, when you understand how the machine learning algorithms are working, this point will be, you will be able to understand whatever the point I am trying to explain. The machine learning algorithms basically try to assign weightage to each of these features, and farm equations. While farming equations, if feature has got good amount of data, right, positive data or negative data, then the algorithm will be able to assign proper weight. And when I say proper weight, proper understanding. Weight is nothing but the understanding. Right? Weight is the pattern recognition. Assigned weight to each feature is the pattern recognition. Right? So in syntactic approach, you will not be able to understand whether like and love are same or not. Okay, in syntactic approach, this bag of words representation cannot do whatever I said, right? It cannot actually combine these two columns and create one, because if you look at a simple data set like this, right, it may sound very easy, but when you are handling documents with hundreds of pages and millions of documents, you don't know which one is similar to which word is similar to which word, and context and the domain also is very important. If you look at Monaba MBBS movie, in that they call the patient as subject. In an educational institution, the subjects are called as subject. The technology or the science, social, whatever is called as subject. But if you are working on an education domain, documents, the words, some words may mean differently, and if you are working on healthcare, some words may mean differently. So you cannot actually create a common set of words that can be represented as one. Right? The point I am trying to make is love and like, both if you can represent as some feature x2 and then combine all these counts into one column, this column will be more dense. Right? We call this matrix as sparse matrix. Right? This column is going to be more dense, and it will, wherever you have one, there will be high score here. Right? That way, the pattern recognition for the algorithm becomes easy. But this is not possible when you are doing a bag of words kind of a representation, or syntactic way of converting text into numbers cannot capture semantic similarity. You call this a semantic similarity. Like and love are semantically similar, right? semantically similar. Syntactically, no. The lexically, you call it as lexical or semantic. Lexically, they are different, but semantically they are same. So this is the point I said. Initially when I started, if you are assigning some number to each of these words, right? If I assign 1 to I, like to 2, and then burger to maybe 10, right? 1, 2, right? The burger to maybe okay, cricket to 11, right? And then I1 don't maybe 100, and then like 1 2, sorry, swimming maybe 12. See this here, what I did, I assigned all the sorry, burger, maybe this is 110, is 120. So burger and pizza, right? I should have assigned a number, maybe idli dosa I should assign 11 and 12, right? So all the food I assigned a number which is close, which are close to each other. All the sports events, sports things, I assign a number that is close to each other. All likes have got 2, and love if I give 3. Right? So this now numerical representation is actually having some similarity, right? Maybe 1000. Do you agree? The numerical representation is actually having some similarity, right? Do you see similarity in this numerical representation? The similar words are being assigned numbers close to each other. Dissimilar words or the opposite words are assigned numbers that are far from each other. Do you agree? How to represent this table, we'll see that later. Okay, we are not going to represent this kind of a thing as a table. Do you agree with this?
Yes.
Yes, sir.
Right, that is called as semantic similarity. Okay, that is called as assigning semantic similarities. So there is a concept of word vectorization or word embeddings. Word vectorization or word embeddings. Okay, so here I said I assigned a number that is close to each other for the similar things, right? And number far from each other, which is which are dissimilar to each other. So this can be done. This particular thing can be done programmatically or automatically on a on a 100-page hundreds of like maybe tens of pages of documents, and then millions of documents are there. You cannot manually assign like this whatever I did. There should be a natural language processing technique, NLP technique, that is doing this. Okay, that is doing this. This is what is called as word vectorization or word embedding. I actually said one number, but in reality, it is going to be a vector. Either it is a 1 number or 10 numbers or 150 numbers. It is going to be a vector. When I say vector, it will be a column, numbers like that, right? So there will be 2, 5, 10, like that, right? This is vector representation. Each word will be represented as a vector. I actually gave one number, but in reality, NLP creates each word a vector. And these vectors, right? Similar words vectors are going to be close to each other. Dissimilar words vectors are going to be far from each other. It is going to generate it automatically. The NLP is going to generate it automatically, which is called as word vectorization. There are concepts called as word to vector, right? And then glove. And then most recently, there are transformer networks like BERT, right? Roberta. Okay, all these are word vectorization techniques. Got it? What is word vectorization? What is word embedding? Did you get it? Any questions there? Any questions there?
Yes, sir. So now assigning these close numbers or far numbers programmatically to do that, how to really do that, sir? Love and like.
That will take around 4 days of class, 4 hours of
Okay,
explanation.
okay, okay,
Word to vec, I'll dismantle everything and show you. Word to vec is the base one where the word vectorization started.
okay, sir.
But that is an intelligent way of doing it, right? So when you are converting text into numbers, the numbers should have similarities. And one more point is that once you convert your text into vectors, there is no way that you can do a machine learning algorithm. You will not get a data set like this. Once you convert each word into a vector, okay, I'm actually dwelling deep a little bit. Once you convert each word into a vector, right? If you take one document, right? One document, doc1, suppose that the doc1 is I like cricket. Okay. Doc2 is these points you need to remember, right? These points all will come again, but I am actually showing you at a high level because you need to know where you are heading actually, where you are, we'll talk about many concepts and especially NLP is confusing. It may not be a great thing, but it's a confusing thing. So you need to have a clear picture on where we are heading. Okay. So the second statement is I like idli. Morning breakfast time, right? So dosa, idli, everything I'm talking. So dark one is I like cricket and dark two is I like idli. Suppose that each word is converted into a 5-number vector, right? I is assigned a vector, maybe 3-number vector I'll take, right? 0, 1, maybe 5. Like is assigned a vector, maybe 10, 2, 3, and then cricket cricket. Right? When what I'm trying to show you is when you convert each word into a vector, conventional way of machine learning algorithms is going to fail, and you need to use deep learning only. Okay, how deep learning helps, we'll see. But what's the problem, right? When you convert your words into vectors, why you cannot apply machine learning? That's the point you need to understand here. How to apply deep learning and how it can help and how it can better make the things better, I'll explain anyway. Okay, but today's whatever I am trying to explain right now is why machine learning will fail. Okay, so for cricket maybe 6, 2, 5, right? And then idli. For idli, it's going to be 9, 3, 2, something like that. Right? So there are no similar words. So I was not bothered about creating vectors which are close to each other. How do you know whether two vectors are close to each other or not? How do you know whether two vectors are close to each other or not?
In distance.
Distance, distance metric, right? The Euclidean distance you can calculate and see, right? Now, if you want to represent dark one as a as a numerical representation, right? Dark one is what? I like cricket. Okay? So the dark one will become a matrix like this: 0, 1, 5, 10, 2, 3, and then cricket 6, 2, 5, right? And dark 2 is I like idli. Okay. So 0, 1, 5, 10, okay, 10, 2, 3. Idli is 9, 3, 2. See, if you have 100 documents like these, what will happen to each document? Each document is becoming a two-dimensional matrix, right? Right? If you represent, right, I explained two things here, right? Bag of words is syntactic, I said. In bag of words, you collect all the distinct words from the data and make them as the features x1, x2, and so on, xn. And from each document, you try to count how many times each word occurred, whether it is 0, 1, or 10, or whatever. Try to put them into the data set, and you form a two-dimensional matrix, and then build a NLP, build a machine learning model. When a new record comes in, you will count how many times those words are occurring in this particular new sentence or the document, pass it to it, and then make prediction. That's the syntactic way. And I said syntactic way cannot basically consolidate the semantic similarities of the words, and it may actually not work that efficiently. Okay, so we thought of doing a semantic way of representing. What is semantic way of representing? Giving each word a numerical representation that actually is close to the words similar to it. Right? Each word will be given a numerical representation, and in the data set, the words which are close to each other will get similar or close to each other vectors. That is good, right? That idea is very good, because semantically, whatever data essence, basically data's essence in text data lies in semantic similarity. Most of the data essence in text data lies in semantic similarity. You are able to represent it using some NLP technique, maybe word to vec, maybe glove, maybe transformer networks, vector representation, right? Somehow, what are those? I'll explain. So somehow there are some tools, right? There is a bulldozer which will actually, dig a big pit. What is bulldozer? You don't know. Don't be worried. I'll explain. What is word to vec, what is glove, and all that I'll explain. So there are some tools that can actually do this kind of representation. But we represented the words, but after representing the words into vectors, each word, each sentence, each document became a two-dimensional matrix. Do you agree? Do you agree?
But how can it be two dimensions, right? If you take this example, it's a 3 by 3.
It is two-dimensional, right? 3 by 3 is two-dimensional, right? Matrix.
Okay.
All right.
Yes, yes.
Here, if you see in the bag of words, document 1 is one-dimensional matrix, right? See, this is one-dimensional. One document actually, came as one row, right? Second document came as one row. But in the semantic similarity, semantic representation, right? Word vector representation, or word vector representation. Each document became a two-dimensional matrix. Do you agree? Do you understand the difference of representing data? Yes, no.
Yes, sir.
Now, can we, if when you are actually trying to build a model, what you are trying to do? You are trying to put everything, all documents in one place, right? All documents here in one place, and trying to have y variable, and then passing it to the machine learning model, because machine learning models can handle two-dimensional data only. Now, if you try to combine all these documents, right, how will it come? How will it become? The doc 1 is going to be 0, 1, 5. Sorry, give me 1, 5, 10, 2, 3, 6, 2, 5, right? That is first matrix. The second doc is going to be 0, 1, 5. Now 10 is going to go back 3, right? 3, 2, like that, and so on. You will have, right? You will have m number of documents. Right? So m number of documents. Some mth document is going to be there. And for each row, there is going to be one flag. Maybe first row belongs to 1, second row belongs to 1, third 0, maybe, and so on. Right? There is going to be y. These are all x's. These two-dimensional matrices are x's. X1, x1 it is. Oh, sorry, not x1, dark 1. Right? This is dark 1, this is dark 2, and so on, dark n. So we have got a three-dimensional matrix now, right? So when you represent your text into semantic similarity, word vectors, your data becomes three-dimensional. Then you cannot apply machine learning. You should be reliant on deep learning only. Okay, so this is better representation, but you need better technique. If you don't know deep learning, you cannot do much on NLP. That's the key point. Okay, you need to understand. There are tools like Spassy and Flare and Stanza. These kinds of packages are there. They'll do up to some extent only. What they give, we can use it, but we cannot. Okay? So there are packages like there are there are what we call it as modules, NLP modules like Spassy, Stanza, Stanford's NLP module it is, and then Flare, I think Flare, F-L-E-I-R, Flare. Right? These are all modules, right? And we will see Spassy in depth, and Stanza and Flare you need to kind of play with it. Okay, so in our course, right, we'll start with the bag of words. And then there is another syntactic representation which is called as TF-IDF representation. TF-IDF, right, representation. That is also going to form a two-dimensional matrix, and we can use machine learning algorithms there also. And then we are going to move into this semantic representation, the word to vector, glove and all that. So in the first part, right, first part of NLP, I am going to cover the bag of words and TF-IDF, and we'll cover deep learning, and then we'll jump into the semantic representation. Once you know deep learning, once you know the deep neural network and convolutional neural network, we will come back to NLP. We'll come back to NLP and look at a semantic representation of data, that is word vectors or word embeddings. And then we'll apply CNN DNN model on a word vector representation, a three-dimensional data set. So we are going to handle multi-dimensional data sets now, right? Images, right? Videos, and the text, everything is going to become three-dimensional. Okay, and then we are going to apply deep learning models on the three-dimensional data. Okay, that's where we are going to head. Any questions so far? If something is going to be explained in future, I'll explain, but any questions? Sasiram, you are actually thinking something, right? When we were actually discussing on bag of words.
Yeah.
Got it? Can I move on?
Sir, how do you create the data set, sir? Is there any process to create the data set? For example, systematic.
Which data set, Andy? This one?
Yeah, this one, first one, syntax.
Yeah, syntactic, right?
Yeah,
So
syntax.
we have algorithms, right? Count vectorizer is one class which takes your text and converts everything into numbers.
Text means like it's read the PDF. For example, it's a PDF file. It's read
PDF we
the.
need to read again. There are
Okay.
PDF. There is a module called as PDF and other. I recently looked at one more PDF reading module. I forgot. PDF 2, PDF 3.
Okay. Those tools are read the text from the PDF and it will generate the syntactic. This one, right?
No, they will just generate the text. And again, you need to pass the text into. I'll show that. You
Okay.
need to pass the text into word count vectorizer, which will actually create this kind of data set, right? And then you will use that data set and build a model. I'll show that now. Now we
Okay.
are going to look at that representation and a naive base algorithm also. Once after that, right, I'll go into how exactly the things work, behind the scenes. What is tokenization, what is lemmatization, and all that I'll go later. Once you have a picture of what we are trying to do, that you looked at a building, already constructed building. I'm trying to show you that that's what we are going to do. Right? Now you start digging and all that, it makes sense. Why you are digging, why you are making pillars, why you are actually doing walls and all. If you don't know where you are heading, right, it's going to be in a Greek and Latin. That's kind of approach I am trying to take.
Okay, sir.
Got it? Can I move on? Okay. So I opened this one, but I am going to go back and open.
One question before
Yeah,
that.
please.
So we have actually represented in the vector form, right? So every word is represented as vector form.
Yeah.
The vector of three elements. So is it a standard or how that is? It could be any.
That's a good question. Any size, right? Yeah, that you can decide. So generally, the vectors are going to be in 150 or 200 or 300 size, vector size.
Mhm.
So here, the question is, are the vectors going to be 3 in length? Right? The dimension of vector is going to be 3 or more. Right? Generally, it's going to be 150 or 200 or 300. But you can decide how big the vector should be. That's another hyperparameter again. On some data, 100 will work. Some data, 25 will work. Some data, 50 will work. To represent the data semantic similarity in numerical form.
So is it a kind of conversion that word is converted into vector,
Yes.
or is
Yes,
it?
Yes, yeah. Basically, this is one way of converting word into number. Right? This is one way of converting word into number only. I am saying vector. When I say vector, right, there will be more essence that can be captured.
So there we
cannot-
have.
You,
Yes.
give me 1 second. If
Yeah.
you see, if there is a corpus, if there is a data set with a million documents, like is a word, that like word given will be given one vector throughout the data set. Got it?
Yes, sir. One vector only, but how the numbers inside the vector are decided.
That is the thing we are going to learn, right? Word to vector is the algorithm. That is one algorithm which actually converts your text into vectors. We'll see how it is converting. When you see how it is converting, right, you will know how meaningfully it converts. There is time, right? We need to know what is deep neural network, and then only we'll be able to understand word to vector. So that's where we're going to understand NLP, some NLP concepts, and how to work with machine learning now. And then we'll learn deep learning, and then again we'll come back to NLP, and I'll explain all that. There is time. It takes a week, maybe around 3 to 4 days to explain the whole word to vector. How exactly the word is converted to vector.
Sir, on the similar lines, basically, there are already, as you said, the existing algorithms are already developed to take care of such generation, like
Yes.
closed vectors, far vectors, all those things. The existing algorithms already developed by doing all that research.
Yes.
So we don't need to do anything. We just need to reuse those algorithms.
Yes, and yes.
Okay.
But you need to know how they exactly work, because
Understood, sir.
like gradient descent only. If you know what is alpha, what is gamma, what is all those parameters, right? You'll be able to play with it and do better things, right?
Yes.
Like that representation, to make the word representation better, you need to understand how it's working.
Yeah, sure.
If we have to build something like that, right, it'll take maybe 6 months or 1 year. So it's a research, may not be sufficient also. So it's a research thing, right? So when we are actually developing, it is always about timelines. Whether you do it correctly or not, nobody cares. No, met timelines or not. That's what most of the people care about. So that's not the right way, but that's how the industry and the world goes. Yeah.
So one more question, sir, on the bag of words, the first conversion.
Yeah.
So here in the second conversion, we are actually trying to give some meaningful vectorization or numeric representation of each word.
Yeah.
Right? There actually, it is the count of the words.
Yeah.
So let's say we have two different words of the same count.
Yeah.
So those will be of the same representation. How
So
How
you'll
the
get
listing?
here, maybe you'll get 5 here, maybe you'll get 6 here, like that, right? So how this is useful, right? That's the that may be one question, and compared to semantic similarity, is it going to work, right? That's the kind of question, right? Is that the question?
How the output variable is identified? In fact, every row is
The
based on the
count is
input.
the weightage, right? The count is the weightage given to that particular feature. In every row, where the record, where target variable belongs to 1, if the number is high here, that means this feature is the most important one, right? So if you have more weightage in the new document, right? Doc6 came in the doc6, if you have 0, I can say maybe this record belongs to 0. If in doc6 you have 10, definitely I can say 1, because when the other documents which I have got how high count in this particular feature, have belonged to 1, right? So if the doc6 is coming in, and then it has got 10 in that particular column, then definitely you can say the record belongs to 1. Got it?
Yep.
So this is, I'll give you one example, right? If you are actually trying to work on a bank form, right? There'll be forms to fill in the bank, right? So there will be name, right, address, and so on, and then there will be a table. Maybe there is a table that actually tries to put some amounts there, right? So some amounts here, right? And in this particular document, right, all the columns are going to be fixed, right? All the columns are going to be fixed. You're understanding, I think, right? So all the columns are going to be fixed, and all the features are going to be fixed. There is not going to be much change in the features, right? And there will be values in the associated with each of the feature. Name is a feature, address is a feature, and then amounts are features, right? And you are trying to do some sentiment analysis model or regression model. It doesn't matter. Maybe sentiment analysis model. Depositing high, activity high or not, activity high or not. That's the kind of model you are trying to build. So if you have these counts, right, somewhere if you have the count, right, high, I am unable to. So, um, uh, no, not that one. So not the name and address, right? Suppose that there is a document that actually has the check boxes, right? Check boxes. Some features are there, and there are check boxes, right? Or there is a feature, and then there is count, right? That feature are yeah, there are drop downs, right? Drop downs, and you need to select them, right? If the particular even if you take 1 million documents, right? Even if you take 1 million documents, the count of a particular feature will decide whether a document is type of a particular type or not. Or sorry, I'm getting confused in creating the example. There are different forms, right? Form 1, form 2, and so on. Form 100, right? If you have 100 forms in your bank, and you want to build a model to distinguish one form from the another, right? What you want to do is, you have scanned documents, you want to pass the scanned document to the model, and model should be distinguishing one form from the other. If you have to do this kind of a model, right, bag of words is the best representation. Okay, I am actually correcting myself and stabilizing a little bit. The problem we are trying to solve is, there are different scanned forms in our bank, and each form, right, you scanned it, and you wanted to build a ML model, right, that actually distinguishes one form from the other, right? So how will we do it? We take these forms and extract all the column names and the headers in the data, right? The form 1 is going to be, right, is going to be a text document with feature 1 right? Feature are the names in the form, right? Different in the form there will be different names, right? Feature 1, feature 2. Give me 1 second. My laptop is having some problem. Okay. So feature 1, feature 2, or the form will have some text in that, right? Text A, text B, right? Text C, like that. And form 2, will have text A, text D, text K, like that, right? Different text it will have. And form 3 will have text A, maybe text K, and maybe text C, something like that, right? Different forms will have different texts in it. Now, if you create a bag of words model for that, what will happen? If you create a bag of word model for that, so it's going to be text A doc1, or form, there are maybe 1,000 documents belonging to form 1. There are maybe 500 documents belonging to form 2. There may be maybe 800 documents belonging to form 3. So your data set is going to have 1800 plus 500 is 1300 records. Your data set will have 1300 records. Doc 1, doc 2, and so on, doc 1300. Now, text A, text B, text C, and so on, right, is going to be your columns, right, are going to be your columns, right?
So
I'm
are you
actually,
writing somewhere, sir?
sorry?
Are you writing somewhere?
Yeah, I am writing. You cannot see?
No,
Yes.
I think the screen is stuck at the previous screen only.
Okay, let me see. There is a problem. My laptop monitor is not working. I connected a external monitor. Maybe because of that. So let me reshare. Yes, I'm seeing this. Now you can see? Can you see?
Yes, sir.
Yeah, yes.
Uh, why are you waiting that long? I was writing a lot, right?
Maybe there is a lag. We were thinking maybe lag and it will display.
Yeah. So, sorry for the technical difficulties here, but no. So here, right, the problem I am trying to solve is I have different scanned forms in a bank, and I wanted to build a machine learning model that will take the scanned forms data and distinguish which form it belongs to. Okay. So to do that, I need to extract data from all the scanned forms, right? There is OCR, right? Extract data from all the scanned forms, and I extracted that data, and there are fields in the forms. So, there is a text field A, text field B, text field C in form 1, text text A, text B, text D, and text K in form 2, text A, text T, K, and text C in form 3, something like that. Okay. Now I am trying to tell you that in this kind of a situation, bag of words is the best model. No need of semantic similarity. Bag of words is the best model. Why? I am trying to explain that. In bag of words, what you do? Document 1, how many times the text A occurred? Document 1, text B, how many times? Text C, how many times? Like this you do. And Y variable is going to be form 1. Right? Which document it belongs to? Y variable is going to be form 2, form 1, like that. So there are 1300 documents you scanned, and you kind of kept the counts in there, right? For form 1, all these values are going to be 1, right? If a new form came in and you scanned it, passed it to the, you built a model now, ML model, right? You pass that scan document to the ML model, it will immediately know if there are 3 ones in the first C, it belongs to form 1. Easily it will be able to distinguish. Got it? In this kind of a data set or this kind of a problem, No need of semantic similarity. Bag of words will work. Sesiram gar, your question only I am trying to answer.
Yes, sir.
Right? Maybe doc2 belongs to form 2 and it has got A1, B1 and K1. Somewhere K1. Right? Maybe somewhere K here. And rest all are going to be 0. Immediately it will identify. The ML model will identify that this belongs to form 2. This document, whatever scan document is belonging to form 2. It's a real-time use case. One of our students actually worked on it in their company. They, he was consulting us to, give a solution. We were initially thinking of this deep learning and all that junk. But suddenly, we got to know that a bag of words will work. It's a 1 hour discussion, and finally we concluded that bag of words will work better than the semantic and deep learning representation. So the techniques, all techniques are useful. There is no one technique is better than other. Some cases one works, some cases other works. Right? Some cases count matters. Some cases meaning matters. Right?
Yeah, in this case, each form has its own representation and standard representation. If the form 1 is coming, its representation is standard.
Yeah,
Right?
because the data is like that.
The data is like that. Okay.
Forms are going to be static most of the times, right? If a bank or a government creates a form, right? Mostly they'll not change it for 20, 30 years. Even if they change, right? Maybe minor changes will happen. But mostly it looks similar.
Yeah.
When the data looks similar, you should go with bag of words. When data is all haywire, right? Different people are writing different analytic reports, right? They'll write reports on companies and the all that, right? So those kinds of documents there will be different text. The different people will write in different ways. The way they use language is also going to be different. Right? Those kinds of things you need to have semantic similarity. If you are trying to build something for those, right, you need to have semantic similarity. Got it?
Yeah, sir, here we are actually not concerned about the exact data filled up in the form, right? It's they're just trying to identify the type of form
Yes.
based on the headings or
Yes.
the
Yes.
captions kind of stuff.
That was the problem they were trying to solve.
Yes.
Or bag of words is bag of word fits well for those kinds of problems. Or
Yes, sir. Please proceed.
at a glance, right, we had looked at what is NLP and what we are going to where we are going to head. Right, from tomorrow, right? Tomorrow I'll show you a naive based algorithm and how to build a bag of words model, and and then right we'll go into the details of tokenization, lemmatization. Okay.